In this video, you're going to learn how to convert your machine instructions to assembly instructions. What is given here, 8B4734 is your machine instruction. Now you have to check first whether whatever prefixes we have seen is existing in the beginning or not. We have the prefixes 66, 67, and also we have seen some prefixes such as segment overriding. First we need to check whether those prefixes exist or not. This instruction does not have any prefixes. That means this 8B47 is your 16-bit instruction, which will give you a opcode, source and destinations. And the remaining one, 34, is going to be your displacement. Now first try to elaborate this 8B47 in its binary form. So 81000, B1011, 40100, 70111. Now this is what you got as a 16-bit instruction format, where you will get your opcode, your D bit, your W bit, and mode bit, REG bit, and R by M bit. Now see this. Try to match this opcode, D bit, W bit, mode bit, REG bit, and R by M bit with this existing machine code given. Now try to decode this. Now opcode is 100010. See, these 6 bits, most 6 significant bits are opcode. Now you all know what is the opcode corresponding to binary combination 100010. That is definitely your move instruction. Now your D bit is 0. What is the meaning of D bit 0? Data is going to the register. That means your destination is going to be a register. So what should come immediately next to move is a register. Which register to go? Which register you have to put here? Once again, that will come from your W bit and REG bit. These 3 REG bit. Now W bit is 1. That means 16 bit. That means the register which you're going to put here is going to be a 16-bit register. Which is that register? You get it from REG bit. Right? You get it from REG bit. That REG bit will come from the REG table. And you see in REG table where this 000 is there. Now 0000 is there here. Now see the corresponding registers here. And you know very well that your register is 16-bit register. Ultimately, the register which you have to find is AX register. And this AX register is going to come here. Half the instructions is done now. Now remaining destination we have to see. You don't know whether destination is going to be a register or memory. That information will get it from a mode bit and also from R by M bit. So using this mode bit information, R by M information, bit information, refer to the table and check where 01 and 111 exist. Where 01 mode bit and 11 register bar memory bit exist, which is your BX plus the D8, which is your BX plus D8. That means it is register relative, right? It is register relative. Now, see here, this is BX plus D8. This is the 8-bit value. Which is that 8-bit value? This 8-bit value is nothing but displacement. And where you have the displacement is there in the machine instruction itself. 3 4, see here, 3 4, this is the 8-bit displacement. This displacement is there in the instruction itself. So this, in place of D8 you put this 3 4. So ultimately you will get your source as BX plus 34H. Ultimately you get your source as a memory. You all know within the square bracket is something existing, means it's a memory. So your source is nothing but memory, which is actually having an offset address, which is the content of BX register and this displacement. This is an example of register relative addressing mode. Register relative addressing mode. This is a relative value. This is 8-bit relative value. The same instruction can also be written as the same instruction can also be written as we have told you, move. You just have to put 34 in the square bracket BX. These two instructions are same. So your decoded machine instruction is this one. All of you understood how to convert a machine instruction to an assembly instruction. We'll see the next example in our next video. This is your this is your assembly instruction corresponding to this machine instruction. We will see next example in next video.